In 3.5 decades of teaching programming, one of the things that students really struggle with is the concept of passing values by value versus by reference. In VB, we have these two terms, ByVal and ByRef. In other languages, the terminology may be different, but the concepts are the same. In C++, we have pointers, and pointers are basically passing values by reference. I think to best understand this, though, we should delve a little bit deeper into the technology that's happening underneath the hood to understand what's going on. And then I think it'll make more sense of what happens when we pass by value versus by reference and why we might pass something by reference over by value. We've seen in the past that we dim a variable, in this case age, as integer equals 55. And that dim statement stands for dimension. It simply means go out into memory, into the random access memory, the RAM chips, and set aside a space with the dimensions that can hold an integer. Now that memory space has an address. So you see there the 12-digit hexadecimal value for an address in memory. But rather than working with that address, we give it a name. We give it a meaningful name, in this case, age. Then we assign the value to that variable of age of 55, and 55 is stored at that memory address. I think you would agree that it's easier to work with that name of age versus the memory address. And of course, we do that in real life. Write on a piece of paper the names of your 5 closest friends. And then next to their names, write their addresses from memory. If you're like me, you probably can't do that because we don't say to somebody, hey, I'm going to 1234 East Oak Street. Rather, we say, hey, I'm going to Jones' house, or I'm going to the Smiths. We give an alias to that address based on who lives there. So it's the same with our memory. We don't want to work with that memory address. We want to work with meaningful names. Okay, nothing new there. But when we create a function, in this case, private function next year, in the parameter list, I'm going to create ByVal, a variable called current age, as integer. Now that ByVal really does the same thing as the dimension statement. It goes out and it creates a space in memory, a different address, and we give it the name current age to work with the contents of that address in RAM. The ByVal simply tells us how we're going to transfer the information from the calling statement to this new address. So in my next line of code, I have age equals next year age. And what that does is it's going to take the value of age, which is 55, and copy that to the location of current age. It's making a duplicate of the value by value. And we can then maybe have a return statement in this function that says current age plus 1. And so 55 becomes 56, and that's what we return. That's what goes into the age variable then at its location in RAM. When we pass something by reference, again, we're creating our variable, placing a value in that. We then have a sub-procedure here called increment year, and I'm passing the value of age to current age, but I'm doing it by reference. And notice that when I create this increment year sub-procedure, it doesn't create a new space in memory for current age. Rather, what happens when I call that function, it passes age to current age, but does it by reference. In other words, I'm not passing the value of age, I'm passing the memory location. And that memory location now becomes the same memory location as age. In essence, I've created an alias to this location, or as we call in C++, a pointer to that location. They're both, age and current age are both accessing the same memory address. So that when I then run my increment year sub-procedure and I have current age plus equals 1, what's going to happen is 55 becomes 56. And that's stored in that memory location for current age, but it's also the memory location for age. So therefore, age now is no longer 55, it's 56. So when we pass something by reference, it affects the variable value that we're passing if it is changed by the method. Let's take a look at an example. To demonstrate this in Visual Basic, I created a very simple application with 2 buttons. one ByVal demo and one ByVal ref. Let's take a look at the code. So the ByVal demo, I have an integer variable called original value. I set it to 15. And then new value is also an integer variable. It's going to equal ByVal demo, and I'm passing original value by value. And then I have a message box that's going to show the values of both the original value and the new value variables. In the ByRef demo button, it's the exact same thing. The only difference is I'm calling a method called ByRef demo and passing original value by reference. Here at the bottom, you see the ByVal demo and the ByRef demo functions. They're identical other than how the value is passed, one by value, one by reference. They both take that passed value and double it and return it. And so that return value is what will go into new value. Let's run this so you can see the difference. And so I do ByVal demo. I'm getting the original value as 15 and the new value as 30. So it retains that original value because we passed it by value. However, when I do the ByRef demo, even though the function is identical except for how we're passing the variable, when I change ABC and double it, that is doubling the value of original value because they are linked together. They point to the same contents at the same address. So here I'm getting 30 and 30. So by altering ABC in the ByRef, it is altering the original value that was passed to it. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.